Hello everyone, we are doing the problems from H.C. Verma chapter number 5, which is Newton's laws of motion. So this is the question number 4 from the exercises. Let's look at the question. A block of mass 0.2 kg is suspended from the ceiling by a light string. A second block of mass 0.3 kg is suspended from the first block through another string. Find the tensions in the two strings. Take G as 10 meter per second square. Okay, so before we solve this problem, what we will do is we will draw a picture. Okay, so before you solve any physics problem, you have to draw a picture so that you will understand what is going on. So here I am suspending a block which is given in this problem from this first string. This block's mass is 0.2 kg. Okay, it is suspended from the ceiling. This is our ceiling. And the second block of mass 0.3 kg is suspended again from the first block through another string. Okay, so note here, it is suspended from the first block. So from first block another string is coming. Okay, like this, and this is the second block and its mass is 0.3 kg. Find the tensions in these two strings and take the G as 10 meter per second square. So we will take this system as a stationary system because it is not given that this is in an accelerating frame of reference. So here first what we have to do is draw the free body diagram of mass 1. So this is mass 1 and this is mass 2. So draw the free body diagram. What is a free body diagram? Free body diagram is a diagram where you indicate all the forces acting on the object of interest. Okay, but you do not include the forces by that object. So okay, for this first mass we will draw this a point. Okay, so you can see from tension here is upward. Let's say it is T1. Since this downward string is also there and 0.3 kg mass is pulling that string, this one, so there is again a tension which is downwards, which is T2. So now if I draw the free body diagram, it will be something like this. T1 is the upward force, T2 is the downward force, and again downward force due to gravity will be there. Let's say this is m1g. Okay, is this system accelerating? No, it is at rest. Okay, so in y direction there is no acceleration. That means T1 must be balanced by m1g plus T2. So T1 is equal to m1g plus T2. This is our first equation. Second equation we will look at is for the second block. For second block, what is happening? This is M2. The string is pulling it upwards with a tension T2. Remember here the tension will again be T2 again, same, because it is a same string. Always remember, in a same string the tension is same. Here the string is discontinuated by this block, 0.2 kg block. That's why here the tension is different, which is we have assumed T1. So there is a T2 tension and there is a M2G as a gravitational force downward. Is there any other force acting on this? No. So here T2 will be equal to M2G. T2 will be equal to M2G. This is my second equation. Now, can I substitute the second equation T2 in this? Yes, so we will substitute it. So T1 will become M1G plus T2. So instead of T2 I will directly write M2G. So here M1 plus M2 times G. So here T2 is M2G. So now from here it can be evident that this tension T1 is bigger than this tension T2, because this string, the first string, is supporting not only 0.2 kg mass, it is also supporting 0.3 kg mass also. So that's why the tension is summation of these two weights, m1g and m2g, and here T2 is just equal to m2g. So here we will be finding out what is T1. So T1 will be, one mass is given to be 0.2 kg and another is 0.3 kg. So here 0.2 plus 0.3, and g is to be taken as 10. This is in Newton, so this is equal to 0.5 into 10 is 5 Newton, and T2 will be, M2 value is 0.3 into 10, that is 3 Newton. So T2 is 3 Newton, T1 is 5 Newton. So this is the answer. So if in an exam, if any competitive exam, if such a question comes, directly write the tension over here as M1G plus M2G, M1G plus M2G for the first string, because it is supporting these two masses. And here in this string, whatever mass is downwards, you will write it like this, M2G. Okay, this is the weight supported by this string. Okay, so this is the way you solve it. Thanks for watching the video.